All right, everybody. Thanks for being patient. We've got a great crowd today. My name is Apurva. I'm a Sysdig member of the Sysdig team here. Really excited to talk to you today. Just one more time, I'll give my news, which I gave earlier for some of you, which is Sysdig announced this morning that we raised $15 million in a Series B. And we have this great Q&A posted with Laura Stagiani, the creator of Sysdig and our CEO, posted to our blog, which I think one of my colleagues just posted to the chat room here. So you can grab that or just hop on to sysdig.com/blog. All right, with that, let's talk product because that's what we're here for. Um, what I'm planning to do during this webinar is tell you a little bit about our product and what we've done, like the technology behind it. I'm going to spend most of the time actually showing you the product because I think that's the most interesting way to have a conversation with you. And I love to get questions from the audience. So what I would love is if you were to ask me questions during this presentation, I'll usually just stop and answer the question right then and there. Otherwise, I'll weave it into the rest of the presentation if it's something coming down the line. And I'd rather be answering your questions than just using my usual talk track. The way to ask me questions is if you look in the upper, I believe it's the upper left of your screen, you'll see a little gray bar, and there's the ability to use chat there, and we'll see all those questions, and we'll answer them as soon as we can. So I appreciate that, and let's get started. Well, so Sysdig has focused on the concept of monitoring containers and the microservices that are built on top of containers. Why does this matter, and why isn't this just a solved problem with existing monitoring tools? Fundamentally, these new architectures break legacy monitoring analytics tools, and of course we solve them. That's why we're here to talk about it. But what I think is more interesting is that as we talk about the technology, we'll show you how at a fundamental level these challenges are different, how we solve them. So there are three core problems with monitoring containers that makes it a different approach. First of all, legacy monitoring approaches can't see inside containers. Containers are designed to be portable black boxes for your code, where you can move them from cloud to cloud, from developer laptop to data center, wherever. The flip side, however, is that typical monitoring tools just can't see what's going on inside the container. But at the same time, containers are designed to be lightweight and isolate processes, which means that it's not a viable solution to simply put monitoring agents inside each and every container. You create tons of dependencies, and you kind of lose the lightweight nature of those containers. So that's a huge problem, which is you can't see inside something, and at the same time, you can't put your agent inside to take a look at what's going on. And then finally, layered on top of that, microservice architectures basically have a different dynamic and a different workflow by which you want to monitor and troubleshoot. And so existing tools simply aren't built with that in mind. So let's talk about Sysdig and how we solve that problem. And where I'd like to start is with our fundamental technology. And we call it container vision. And when you deploy Sysdig Cloud's agent as a container on your host, you can fundamentally see what's happening in other containers that are running on that host, as well as the underlying infrastructure of the host OS, the network and infrastructure, and any additional tooling you have. So from this one single vantage point, you can see everything going on in the system, and you don't have to put any special agents inside the containers that you're operating. So I want to talk you through a little bit of how this works, and then I'm going to stop for questions. So let's take your host here, your imaginary host here, where you've got a bunch of applications and you've got a bunch of containers running, and they're all interacting with the underlying host OS through the kernel. Sysdig's approach has been to basically instrument the kernel, and we do this through a unique kernel module that we've open sourced. So that's available. It's available from our GitHub repository. It's also packaged up now with a lot of the Linux operating systems. So it's kind of gotten that far along that it just basically comes by default. That you just have to start it up. Now, once you've instrumented the kernel, we see every system call that every single container or every single application not in a container makes to the kernel. From that vantage point, we can now collect data into the Sysdig container itself for collection and analysis. So the beauty here is by one point of instrumentation, you can passively collect all the information that's created by different applications and different containers without actively trying to instrument each of these units that are operating inside your host. And so that produces a really powerful way for you to simply get visibility into your environment. And then the next section, I'm actually going to show you what type of visibility you get and how it's much more powerful than typical infrastructure monitoring tools. But this is usually a pretty good place to stop and see if people have questions on the core instrumentation of Sysdig Container Vision. Let's see here, I'm going to just check my chat window. Okay, so first question just came in, which is, do you have to do anything special to enable this type of collection? There are two things that you need to do for the model that I'm showing you in the screen right now. First of all, is you have to enable kernel headers. And secondly, Sysdig's container is deployed as a privileged container. So those are the two requirements. They're very, very simple. They're one-line commands. One-line commands in your OS. You can package those up as part of your default OS in order to automate the deployment of this as well. Great question. Any additional questions so far? Cool. Let's keep going. So with this kind of instrumentation, you actually get better visibility than you were able to get with typical infrastructure monitoring products. When you think about typical infrastructure monitoring products, they'll give you information about the CPU, memory, and disk, and similar information about a particular host, and allow you to do a good job of graphing that stuff and alerting on it. But I mean, that's not really very powerful when you have a highly distributed, highly containerized environment where you need to not only monitor the containers, but you also need to understand the applications inside those containers and how they're performing as a whole. So with Sysdig, you get 3 different levels of visibility that we're going to cover in detail and also talk through with the demo. First of all, service-oriented performance management. This is about thinking about the services that you create aggregated across many different containers. And how are they performing? How is the user experiencing your application? Next is application intelligent monitoring and alerting. One thing I did not mention on the earlier slide is when we instrument the kernel, we not only see what the container is doing, we see what the application inside the container is doing. And that means we can tell you passively, without you having to do any active work, what applications or components you have running and how they're performing right now. That really changes the way we can help you alert on the performance of your system. And finally, trace-driven troubleshooting. So most monitoring products tend to stop at the pretty graph of a time series data. It kind of looks like this, and maybe up and to the right for the spike when something goes wrong, and then they leave it to you to figure out how to troubleshoot that situation. We've actually created a much deeper set of tools that allow you to troubleshoot your system all the way down to individual system calls, and we also leverage our open source Sysdig capabilities as part of that. So I'll show you that as well. All right, so now I'm going to walk through each of these in a little bit of detail, starting with service-oriented performance management. So as you can imagine, if you're familiar with using a containerized environment, your containers tend to be distributed across many different compute nodes. They could be in different clouds. And if you're using an orchestration tool like Kubernetes or Mesos or DCOS, you're used to the fact that the container scheduler is pushing those nodes somewhat at random pushing those containers somewhat at random through those nodes in order to achieve high utilization. That's great in terms of optimizing your underlying compute utilization, but what happens when it comes to monitoring a particular service that you have, right? So what if you want to know how well your database is doing right now? It's a pretty hard question to answer. So what we do is we actually leverage information that allows us to aggregate containers based on services that you're providing, and by the nature of that, allow you to then answer the question, how is my particular service doing? And an example down below, what are the slowest URLs for Cassandra, which I know is running across multiple data centers in my containers? Now that's actually a hard question to answer today, and especially without doing custom instrumentation of your Cassandra cluster and requiring your developers to do some significant work. The way we achieve this type of depth is through a deep real-time understanding of orchestration tools and their metadata. So what we do is we interface with both orchestration tools and underlying cloud platforms, and we collect metadata in the form of labels and tags that tell us what are the characteristics of your system. Then, as I'll show you within our environment, we allow you to dynamically you kind of recreate the hierarchy of your system in a way that allows you to answer questions like, how's my Cassandra service doing? How's prod doing? How's my, if you're a Kubernetes fan, how's my replication controller X doing? And so on and so forth. So this is really part of the power of our system and allows you to understand your software logically instead of just physically. All right, I'm going to take a sip there. My throat's hurting a little bit, but this is a good chance for questions as well. I would love. My colleague just asked the question I was about to ask. I would love to hear what orchestration tools, if any, you're using right now. If you wouldn't mind chatting us in, whether you're using or looking at a particular set of tools, that would be really helpful, because then I can actually tune the demo a little bit and maybe show you some of those tools in action, as opposed to just a plain vanilla demo. So I'll just keep going, but would love for you to chat in and tell us what kind of orchestration tools you're using, whether you're using public clouds or private clouds, and any information along those lines. Okay, so we just talked about service-oriented performance management, and kind of being able to aggregate the containers into views that really matter to your services. We also do application intelligent monitoring and alerting, and one of the things that container vision gives you, as we talked about, is the ability to see inside the container, to understand what app is actually running inside there. And we can automatically discover those apps. So you don't have to do any work to figure out, well, is this container running MySQL? Well, let's see, the scheduler just spun up 10 more containers. What are those containers? How do I have to instrument those? Do I have to tell my developers to do something special? You don't have to do any of that. We discover that for over 50 application components today. You can build automatic discovery for your custom apps, and we make it really simple to get that data. We also make it really simple to view that data by creating pre-built templates by applications and services. Of course, you can build your own dashboards, and we'll show you that, but it's really helpful to walk into an environment where you're like, okay, there's Nginx in there. Why don't I just look at an Nginx-based dashboard? Zero config custom metrics. So if you're doing statsd or JMX metrics, we see those out of the box. You don't have to do any additional instrumentation, no agents. Basically, the metrics just have to get written out to localhost. I'm disappointed to say that nobody has chatted in on what orchestration tools they're using, or even said they're not using any. So I'm calling you guys out: Alex, Amir, Girish, Jefferson, Matra, Manu, Sach, Victor. Come on, help me out. I know you're there. I know you're real people too. Let me know what kind of orchestration tools you're using. And then let's see, one last point here, which is, in terms of application intelligent monitoring, we also try to simplify the alerting process through anomaly detection and outlier comparison. We'll again talk through that in a little more detail. Here's a quick view of all the apps today that we automatically discover, or I would call it components. Components kind of is a more appropriate word. But I'm sure there's something here that y- I'm sure there's something here that you use on a regular basis. And if there isn't, we regularly release new application discovery components. So we'd be happy to work with you to make sure you've got what you need. Thanks, Manu, for the answer. Appreciate it. Just an example of how powerful this is. So last night, developers spun up a new service based on Apache and Mongo. It was an emergency. They needed to get this thing up and running, so they didn't, worry too much about instrumentation. But if your automation scripts just include the Sysdig container, you automatically get all of your metrics, not only for those containers, but for Apache and Mongo as well. Pretty cool. And finally, trace-driven troubleshooting. So as I talked about, most monitoring tools stop at showing you a dashboard, showing you some alerts. We do a few other things that help you get to the root of a problem in a very deep way. So first of all, we do trace-driven troubleshooting, meaning we take your dashboards, we let you correlate events with them. Those events could be alerts, where you're saying, hey, the alert occurred right here. They could be events like custom stuff, like your orchestration system pushing out information, your continuous build system pushing out information, developers committing code. You can see all of that right on your charts and filter the right messages. And then finally, when something does go wrong, you can capture a system, you can do a system capture. And a system capture actually it makes a file of every single system call going on that particular host at that time. So the power here is that in a highly dynamic, variable, containerized infrastructure, you may have a problem with a container and you want to kill off that container. Well, in that case, you can kill off the container, and if you've captured a trace file, you can actually troubleshoot the system even after it's long gone. So you could get to the heart of whether it was an underlying infrastructure problem or an application problem causing that container go haywire without you having to keep that in your production environment. It's pretty powerful. And Alex just pointed out, we mentioned a bunch of mentioned a bunch of orchestration tools, and he's working with a homegrown orchestration tool, which is awesome. We can totally integrate with that. Obviously there may be a little bit more glue that we need to put in place, but if you have some concept of labeling or metadata in your orchestration system, we can typically tap into it and make it work for you. All right, talk is cheap. Let's do a demo. I want to show you the system at work here. And give me 1 second while I get this set up. If you have any additional questions, this is a great time to drop them in the chat window. Now I know you guys are there and you know how to use the chat window because I got some people chatting in. But now you can start asking your hard questions. We've gone through most of the material, and I'm going to hop into the demo now. I'm just getting it set up on my end, which will just take a second. Question just came in about pricing, and yeah, we're going to talk about pricing in a minute. The high level is that it's per host based pricing, and we do that on a monthly or annual basis. All right. Just going to log into the right environment here. We're going to do a couple interesting things here, which is I'm going to show you an environment that's running, and pretty not super complex environment, but reasonably complex environment. But the other thing I'm going to do is I'm actually going to show you how we instrument systems. So my feeling is that there are very few monitoring tools that are out there where they actually show you how they instrument the system. They kind of they kind of all assume that you'll go do the work to instrument the system and you'll get your information in, whereas we think it's kind of part of our core differentiation. So I'm going to share my desktop now that it's set up. All right, so hopefully now you can see my web browser with some interesting Sysdig Cloud goodness going on, just chat into me and to make sure that I can that you can see the window properly. Cool. Okay. Great. So what we're looking at here is one of the cool features of our product, which is a real-time topology map. Let's go. Actually, let's go real time here. And what we're doing here is we're looking at a service-oriented view of our infrastructure. You see here we've got a front end. We're running this in AWS, so we've got ELB in front of our front end, and we've got a number of data services here running in the background. Now, this doesn't say anything about hosts, doesn't say anything about containers. This is just the actual services that we care about. These are configurable, but right now we're looking at CPU and we're looking at request time between these elements of our system. Now, if I zoom in here, I actually see that this service is made up of multiple hosts. And if I keep zooming in here, we can see that in each of these hosts are containers running. And so we can get a very deep view into what is going on with our service, what containers make up that service, and how is it performing. And we can do this in a really dynamic, logical way that applies to how we expect our application to be running. And this is pretty cool in terms of a high-level view of telling you how are things performing right now, and what problems, if any, do I need to assess. Okay, so this is pretty cool. We're going to come back to this environment in a moment, but as I mentioned, we're going to start by saying, how did we get here? How did we get enough information into this system? And in order to do that, I'm going to go into a blank environment and show you the actual instrumentation process. So here, you can tell this is a different Sysdig Cloud environment. This purple bar is the easiest way to see it, and that's just my trial account. And let's see, let's hop over to a terminal window. Let's see here. Let's hop into Amazon. Okay. Let's take a look. All right, cool. So what you're looking at now is an Amazon host that I have running, and it's got a very simple application running. It's a MySQL and WordPress application. Now, in order to instrument this system, we're going to grab a very simple command. Let's go over here to settings, go to agent installation. You'll see here there's a Docker container install. If you're using us in a non-containerized environment, you might want to install us directly on CoreOS or directly on Linux. These are all out-of-the-box options. You can copy and paste these. I'm using Docker right now, so I'm going to use this command. Copy my terminal. Oops. Paste this in. All right, looks like I have a little problem here. This is what happens during live demos. So this is obviously a trial host I've used before. So let's get this running. All right, cool. So what we're doing right now, I ran that Docker run command. I had to kill my old agent off before. As you can tell, I've done this demo before. But now what's happening is Docker is pulling down the most recent version of our agent, and it's instrumenting the kernel, as we talked about. And as soon as it does that and sets up our container, it begins sending information back to Sysdig Cloud. So let's hop back over to Sysdig Cloud, and it usually takes a few seconds, somewhere between 10 and 20 seconds, to collect the first bit of information. But as that information is collecting, we'll begin to see it here in the Explore table. So now what you see is an individual host that's been instrumented. That's cool. Now, let's go a little bit deeper. As I mentioned, container vision gives you a lot of intelligence right out of the box, or at least that's what I claimed. So this Explore tab is kind of like a big pivot table of your infrastructure. So I can drill down here, and we can see the actual agents running in this environment. And this is great information. CPU CPU, memory disk. This table is totally configurable, so I can get exactly what I want. But you can do more of this with this. I can click on MySQL, and what happens is now I get these views, which actually drill into this particular container or the selection of containers that you've chosen. So here I'm getting a container overview. And we do know that we were running MySQL here. So instead, let's go to a MySQL specific view. And not only will we see stuff like CPU, memory, and disk, but we'll see very, very specific MySQL related metrics, like requests, request time, top queries by number of requests, top tables, slowest and slowest tables. There isn't enough information to fill in this top table and slowest table since I just instrumented the system. It would appear if we were running it for a little bit longer. But what you've seen is not only were we able to instrument the whole single command, we didn't have to do any container instrumentation yet. We could see the containers that were running. And more importantly, we could click in here and see inside the container to what MySQL was doing. And that's all with one simple installation command, kind of right out of the box. And that's container vision. That's the power of our instrumentation process and what we enable you to get. This is particularly valuable when you are working with containers in a dynamic environment where you don't have time to actively instrument a system. You have to ensure that you can just run something and it will pick up all the relevant information. All right, now I'm going to hop back to my other environment and keep going with the demo. As always, if you have questions, please just drop them in the QA and we'll or in the chat, and we'll be able to answer them as quickly as we can. But that covers kind of the container vision and the instrumentation of the system. Now I want to get into showing you the elements of visibility that we talked about in the presentation. All right, so let's start by looking at the web application. And now we're using a dashboard that we've created. It's really easy to create dashboards in our environment, and I'll show you how you could add something to a dashboard, for example, in a moment. And I'm going to switch out of real-time mode, and real-time mode is data visibility here, basically on a per-second basis. And let's switch to a 5-minute mode here. So now what we're looking at is your web application. And what is a web application? Well, it's really an aggregation of performance metrics across multiple servers. Where you saw before, we saw the front end service that's represented here with deeper metrics. Of course, we get things like bytes that are being transferred, but you get request time, you get HTTP error counts, you get slowest URLs and top URLs. And so this is a really powerful way for you to say, to help you understand, well, how is the actual service itself performing? In reality, I don't care so much if my CPU for my particular container is running at 85%. I mean, sure, if we're getting deep into troubleshooting, maybe that's relevant. But for the most part, what you'd like to monitor is the service itself and how it's performing. Since I actually out for my dashboard, I can just show you kind of how easy it is to create dashboards and edit them. So you have kind of full control over size and layout of tiles within a dashboard. And we'll get more into this. Here's here, show you a different kind of integration. We also deeply integrate with AWS through the API, and using this information from the API and through information we collect from our other agents running in your environment, we can show you a lot more about AWS services than you typically get to see. You might recall from the topology map I showed you in the beginning, we had a box there for ELB. We could show you what ELB is doing. We can show you things like latency. This is ELB latency, in fact. We can show you interesting things like slowest tables for RDS. The Amazon data service. So you have these things that you can't even get from the AWS API, like slowest services, or slowest tables, sorry. Okay, final dashboard before we hop into a little bit more of a troubleshooting view and also understanding how we create these service-oriented views. This service is Mongo, and again, very similar story to what we were looking at before, which is, let's understand how my Mongo is performing as a service and not as an individual container. You see things like available connections, how many update operations are we doing, where are requests coming from in a simplified topology map, request time, top operations, so on and so forth. This is really cool and powerful. Let's talk about where it comes from here. And in order to do that, I'm going to hop back to the Explore tab. Okay, let's see here. All right. The Explore tab is a really big pivot table of your infrastructure. And it's a really powerful way to dynamically examine which is really I mean, I think the most common thing you get looks like some kind of basic list of your hosts or a list of your containers. And that's kind of leaves it at that. But let's go through a little bit of an example here, just to show you how we were able to create those service views earlier. As you saw in my previous examples, you can look in IP addresses and what container running, but in reality, most of us don't think in IP address space. You're like, oh, it's very rare that you say, oh, there's a problem with 10.4.0.159, unless you're actually deep in troubleshooting. The question starts out more so like, hey, looks like our service is on the fritz. Looks like maybe it's the billing service. Looks like it's the auth service, something along those lines. So how do you get from here to talking about the auth service or the billing service? And this is where that concept of metadata comes in that I talked about before. We get metadata from many different systems, orchestration systems, underlying clouds, anything that can provide us labels. Maybe you're using a kind of an infrastructure automation solution like a Salt or an Ansible or something like that. We can kind of get information from there as well. And using that information, we can apply your metadata to create a new hierarchy for your environment. You could do that with things like AWS Elastic Container Service, Kubernetes, Mesos, and Marathon. We have all these different ways to apply metadata. These are default views. You can, of course, create your own. Let's apply the service view. And for our demo, this service view now converts it so that we're using our container labels that then allow you to drill down by container ID. So here you see, for example, HA proxy has 3 containers underneath it. And so if we were to click here, this view is giving us an aggregate view of all the containers running HA proxy. And if I wanted to go deeper, of course, I could click on one of these HA proxy devices and just get specific information for that particular container. All right, so let's go into Mongo and take a look here. I chose Mongo because this is kind of where we're going to do a little bit of troubleshooting and alerting. And you can see, kind of some normal stats here that you might be looking at, some interesting things also like average and worst application response time. You can, as I mentioned, you can very quickly and easily get any of this stuff out to a dashboard. How do you do that? You use these buttons here. You choose pin to a dashboard. You can create a new dashboard, or you can use one of the existing dashboards. So if I started typing, for example, like web, it immediately gives us that dashboard we were looking at before, web application. If I were to type something that doesn't exist, blah, blah, you can see, you can pin to create a new dashboard and simply pin it. And of course, it's a kind of simple and easy dashboarding methodology. We also have a wizard-based dashboard creation process that I can show you in a moment. But let's create an alert instead, and you do it very similarly. We're just going to add an alert. This is GUI driven. You can actually do pretty much anything in the GUI via API as well. We're just about to release also a Python wrapper for the API. So if you're keen to use that, it's available. Now, we do something really interesting here on alerting called adaptive alerting, where what you can do is you can set the scope of your nodes to watch via these tags that I discussed before. So if we apply a tag like MongoDB, what this means is the alert will apply to everything that inherits the MongoDB tag over time. So if tomorrow your orchestration system spins up 10 more MongoDB labeled containers, they'll automatically get this alert. You can set a condition, which can be either a manual baseline, which is a form of anomaly detection, or host comparison, which looks for outliers. Then you can set a condition where you want to alert. So you can choose a metric. You can choose a time aggregation or a group aggregation, and then you can provide a value. Interestingly, here, you can also do multi-condition alerting. So in multi-condition, when you go to advanced mode, you actually lets you do Boolean logic to create a more complex alert. So you may not want to alert on CPU alone. You may want to alert it on if network traffic goes up and number of connections exceeds X, then you care, so on and so forth. I'll go back to basic mode for now. You can do any segmentation that you'd like here, so you can kind of alert across the whole scope in aggregate, or you can do it across some sub element of scope. Now, if you can also set basically a threshold of time. So it's not like if to avoid alert flapping, basically, you can say, well, make sure this condition persists for this amount of time before alerting me on it. Then you set some basic information here based on name, description, and severity, and you choose how to take action on the alert. And this is the other part that's interesting for us. You can, of course, send an email. You can push to Amazon SNS. You can report to PagerDuty. You can also create the Sysdig capture that I was talking about before. And when you create a Sysdig capture, this is where you're going to capture every system call on that host when your alert triggers. So you can either store it in Sysdig Cloud, or you can set up your own Amazon S3 bucket as a storage area. You choose a file name and you choose a time frame for the capture. You can also enter a filter here using the filter syntax of the open source Sysdig tool, and that will allow you to capture a very specific set of information if that's what you're looking to do. All right, so I'm going to cancel out of there. We're going to assume I've created that alert. In the alerts tab itself, you see a list. This is kind of a very Nagios-like view of all your alerts and which ones are enabled, and kind of just general information about that. If you want to see the output of your alerts, you actually go over here to events. And there are two kinds of events we have. We have alert events and custom events. I'm going to get to custom events in a bit, but I'm going to start with alert events. Hop over to alert events, and you can see alerts that have fired. So let's see here. Let's take a look at this guy. This looks like an emergency alert. When I click on it, what I get is a view showing me what the alert is. Network traffic on port 80 fired for the Mongo role. And I see a quick graph of, hey, what actually happened and the point at which it happened. Now, what I can do here are two things. If I've captured a trace file, then I can go open that, or I can go explore this notification back in time. So when I click Explore Notification, it takes me back to Explore, but it sets the time for an hour around the alert, and then brings me back into my environment, and I can see that Mongo's highlighted, and I can actually see the information itself. What I also see is this overlay, which is actually showing me the notification. So this notification is that there were two events at this particular point in time. You can filter showing these notifications here pretty dynamically. So you can choose what events you want to see on the chart. And you can filter based on a search. You can include events related to other metrics or other nodes. Pretty powerful and flexible. Now, just one second. I think we've got a question here. Let me hop into my chat window. Can you create an action for an action for an alert, such as killing and restarting a process or removing temp files? Great question. So today you cannot create, hold on, I'm thinking about it. With our new API functionality, you may be able to do that. So let me answer it this way. Out of the UI today, you could not create an action such as killing a process and restarting it. You would fire off our alert to a different service that you own and create that would take that kind of action. Now, one place where I have to pause and I need to get you more information, Alex, is you may be able to do that with an integration based on our API. And I'll have to get back to you on that one. So I'm going to make a note of that and get back to you as to whether or not we could do it directly from our API. Great question. I love being stumped. Double bonus points for Alex today. Good job, Alex. All right. I'm looking for the next person to stump me. While that's happening, let's get back to our troubleshooting example. So here we're segmenting by server port. That's not particularly useful. Let's look at container, because this is these are Mongo containers. So we're like, well, is something wrong with Mongo? And while net traffic spiked, but net traffic for Mongo seems to go down at this point in time. So it doesn't look like Mongo, the container itself, is a problem. So let's just see what other processes are running on this host. And what we see is, oh, okay, what is this process? This process is called main. The process of main itself is what's spiking at this point in time. And this is kind of the smoking gun. Looks like somebody's running a process main here that's causing all of this traffic. It looks like it's a Python script, and we could troubleshoot it from here even more deeply, maybe going directly to your developers. Also, we could hop into the Sysdig open source tool to do that. So I'm going to take just a quick second for those of you who are familiar. I'd love to know via chat how many of you have used the open source Sysdig tools, Sysdig or Sysdig. If you could chat that in, that'd be great. Let me just run here. I'm running Sysdig, which is our curses-based interface, and I'm using the capture file that we captured for this Mongo traffic alarm. And you'll see what it's doing is it's pulling the file in. It's this is like an on-demand processing tool that allows you to troubleshoot your processes really deeply. So this is 60 seconds of processes running on that host when that alert fired. And here we could now, great, this is certainly a lot of information. We could filter views. We could do views based on processes, CPU. We could actually even do it on things like the containers. And so when I click here, we reprocess the file, and we can actually see information about, in this case, because this host only has Docker container running Mongo, we can see this information. And now we could dig in and understand what's going on even within this particular container and the processes around it. So this is kind of that deep integration we talked about, getting from, kind of looking at a dashboard, correlating alerts, and then getting all the way down into trace files where we see the individual commands run by particular containers or by particular processes on a machine. Okay, hopping back here. So here's what I've shown you so far. I've shown you service-oriented performance management and aggregating information into services that you actually care about versus the underlying infrastructure. I showed you, how to do application intelligent monitoring and how easily we can understand what your apps are doing. I took you through a troubleshooting example from creating an alert all the way down to troubleshooting that alert. There's two more things I'd like to show you very quickly. One is this very new capability that we added, which are custom events. And what you see here these aren't events that are alerts, but rather events that you decide to put into the system. They may look like custom messages. They may look like code commits. They may look like production pushes. And you can get that same overlay effect that you would in, that we did during the alerting workflow. So that's really simple, really powerful. It's really new. In fact, it's so new that I haven't really worked it into my demo flow. I've got to be entirely honest. Um, One last thing, which is just kind of a nice feature to have. We're talking about dashboards and talking about how simple it is to create dashboards. I mean, honestly, we know that for monitoring products, dashboards are the primary way that people interface with them. Our wizard for creating dashboards allows you to start with a default view based on what we believe are some best practices around monitoring these particular tools and environments. So as opposed to from starting from scratch every time, you can choose something like PostgreSQL and then set a scope where you can say, well, give me a PostgreSQL view for everything that's in prod or everything that's in dev, and then create a name for your dashboard, and you're good to go. So this sort of simple way to create dashboards and let you dynamically add to dashboards from the Explore tab is pretty simple and powerful. All right. I think there was one more question here. Just a quick, as I take a look at this, just a quick wrap up. So first of all, we've got a couple different products that you should know about. We've got Sysdig Cloud, which is our hosted offering. So we run the back end. We make it really simple for you to get information from your agents into our back end. It starts at $20 a month a host, and it's discounted for a large server volume. Monthly or annual. We also have an on-premise version of our product. So if you're under high regulatory constraints or you prefer your data where you can hug it, we can put our backend behind your firewall or in your AWS domain, and we do that. But the only requirement there is typically there is a minimum commitment required. And then finally, we have an open source product, which is what I was showing you at the end, which is a great way for you to troubleshoot a single host, and it's community support based, and it's a powerful product. We have hundreds of thousands of people who've downloaded the Sysdig open source project to date. So I hope you've enjoyed this and this has been valuable for you. We just want you to try the product. We think that's the easiest way for you to understand how it would work in your environment. As I showed you early on, it's super simple to instrument a system and get it working. So trialing this product is much faster than trialing a lot of other products I've seen. You can get this running today from a free trial on our website and start seeing these core capabilities that we talked about based on container vision, getting down to service-oriented performance management, application intelligent monitoring, and trace-driven troubleshooting. If you have more questions, we'd be happy to answer them. At this point in time, if you have questions about particular integrations, certainly I can answer a lot of those for you. One final point, which is we do this webinar every single week. So if you've got colleagues who you think would be interested in this, and you're kind of trying to assess whether or not this is the right thing for your team, just send them our way. We'd be happy to either have them on the next webinar, or frankly host a webinar specifically for your team where we can go deeper with your questions. So with that, that's the end of my prepared presentation. I really appreciate everybody sticking around for the whole presentation. If you have questions or comments or things I haven't addressed, this is a great time to ask them. So I'm just going to sit tight here and see if you have any additional questions. So one question just came in is whether or not this can run on clouds other than AWS. Yes, absolutely. We can run on most clouds. Basically, vanilla Linux is what we need to run. We do great with Google, and we actually have a lot of deep support for GKE, their Google Kubernetes engine. And Azure, we can run on Azure. We can run on Rackspace. And I believe we've got people running us in a few other places as well. So no problems there. Okay, another question came in regarding Sysdig versus logging tools, and specifically Elk Stack. That's another great question. People, they're pretty different tools. Like a logging tool is frequently used by developers to capture really verbose and semi-structured log data, whereas a tool like ours is designed primarily to start by collecting significant metric data. And that's how we create a lot of our views, is all based on metric data. We do collect events, as I showed you, but our main purpose is not to collect terabytes of logs a day, but we provide you a much leaner, much faster, much more scalable way to do your monitoring, high-level troubleshooting, and we allow you to um, we allow you to then drop into logs only when you need them. Let's see, another question came in. Let's see. It's a pretty complex question, Alex. I think there are 2 or 3 questions built in there. Certainly, you could run this against synthetic transactions in the sense that if you instrument your, let's just say it's your test systems. If you instrument your test systems, you can instrument against synthetic transactions. I think the thing that you may be asking, which I'll try and answer anyway, is you may be asking, well, can I trace every single individual transaction with Sysdig? And we do not do individual transaction tracing. We do high-level aggregate transaction tracing, and that's the map that you saw at the beginning of the demo. And that's showing you in aggregate how transactions are performing between containers in your system. You may also be may desire to see inside a particular container and what methods or functions are being called inside that particular container. That's a functionality we today don't provide. We'd love to work with you if that's something you'd be interested in, but today you wouldn't be able to do that. Great question. All right. Well, I think I may have exhausted all your questions. Going once, going twice, going 3 times. All right. Thank you so much, everybody. I really appreciate your time and effort. We'd love for you to start up a trial. If you do have more questions that come up after the webinar, feel free to email us at info@sysdig.com, and we'd be happy to help. Thanks, everybody, and have a great Thursday.